Pluto, a distant and enigmatic celestial body. Pluto, a distant and enigmatic celestial body, once belonged to our solar system's planetary family. However, recent alarming statements from prominent astronomers, such as Neil deGrasse Tyson and Michio Kaku, have pushed Pluto back into public attention. They have made shocking claims, suggesting that Pluto might be on a potential collision course with Neptune. But how could such an event happen? And what would occur if it did? Is it a rare cosmic anomaly, or is there something more to this imminent cosmic impact? Join us as we explore the possibilities of a potential Pluto-Neptune collision. Pluto, once classified as a planet, but later redefined as a dwarf planet because of its unusual orbit, continues to captivate the scientific community. As revealed by recent research by well-known scientists, Pluto's course is dangerously close to the orbit of Neptune. Famous astrophysicists like Neil deGrasse Tyson and Michio Kaku are raising alarms about the potential for a catastrophic collision between these two celestial bodies, a scenario that could pose a significant threat to Earth. But how could such an event come to pass? Unlike any other planet in our solar system, Pluto's journey around the Sun is highly unusual. It takes a remarkable 248 years to complete just one orbit. Since its discovery in 1930, Pluto hasn't even completed one full orbit, enhancing its mystique. Pluto's orbit is not just slow, it's also highly elliptical, vastly different from the more circular orbits of the larger planets. To complicate things further, Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system. This inclination makes its path much more extreme than that of other planets, introducing new levels of complexity to its movement. One of the most intriguing aspects of Pluto's orbit is its interaction with Neptune's. For roughly 20 years of each orbit, Pluto comes closer to the Sun than Neptune does, defying what we might expect based on the planet's relative positions in our solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other celestial bodies, especially the large planets. The study of Pluto's orbit began shortly after its discovery. Early astronomers were puzzled by its strange path. Unlike other planets, whose orbits are somewhat aligned with the ecliptic plane, Pluto's orbit stood out due to its steep tilt and elliptical nature. The fact that Pluto's orbit crosses Neptune's was a major point of scientific curiosity. Despite these irregularities, the stability of Pluto's orbit is a remarkable feature of space mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves understanding how three objects move and affect each other through gravitational forces. Predicting their paths is a complex task. This is where terms like IML libration, VZK wobbling, and scope libration become relevant. The concept of IML libration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 dags away from Neptune, ensuring their trajectories do not intersect. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it gets closest to Neptune or any other large planet, it is positioned above the plane of their orbits, offering extra protection from potential collisions. Another crucial factor is the VZK wobbling, named after the researchers V, Z, and K, who studied how space objects interact through gravitational forces. This phenomenon explains how the gravitational pulls of Pluto, Neptune, and the Sun influence each other, keeping Pluto's path stable despite its apparent erratic behavior. Even though Pluto's orbit may seem unpredictable, this wobbling mechanism helps maintain its steady motion over long timescales. These complex forces ensure Pluto's orbit remains stable, preventing it from colliding with Neptune or deviating wildly. The three-body problem is essential for understanding how orbits change due to the gravitational influence of multiple objects. Studying this helps us gain a deeper understanding of Pluto, our solar system, and even celestial bodies far away. Mathematical simulations conducted in the late 1980s revealed that although Pluto's orbit has stabilizing factors, it is still chaotic. Small changes in its starting conditions could result in significant differences over millions of years. Despite this inherent chaos, Pluto's orbit remains stable over incredibly long time scales, effectively keeping any potential disruption in check. Recent computer models have provided new insights into how the gravitational effects of planets, the size of Neptune, Jupiter, and Saturn affect Pluto's orbit. These models show that Pluto's relationship with Neptune is unique. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance helps stabilize Pluto's orbit, but Neptune is not the only force at work. Jupiter's gravity plays a key role, as does Saturn's, providing additional stability. These simulations demonstrate that Jupiter's gravitational pull alone is strong enough to ensure Pluto remains in a stable orbit for billions of years. Together, Neptune, Jupiter, and Saturn work in tandem to keep Pluto safely on its course, avoiding any catastrophic collisions or other disruptions. These forces of gravity are essential for maintaining order in the solar system. Without them, the system would be much more chaotic, with planets and dwarf planets like Pluto potentially colliding or being ejected from their orbits. To get a better understanding of our solar system's dynamic nature, studying Pluto's orbit is essential. Pluto's case serves as a prime example of how even the most seemingly unstable orbits can achieve stability through the intricate interplay of gravitational forces. It also underscores the importance of continuous observation and research to better comprehend our place in the universe. The study of Pluto and its orbit illustrates the unpredictable nature of celestial mechanics. The concept of orbital chaos, which refers to the extreme sensitivity of a body's orbit to its initial conditions, is clearly visible in Pluto's case. Even the slightest modification in Pluto's position or speed could significantly alter its orbit over time. Simulations have played a pivotal role in helping researchers understand Pluto's motion. These computer models use complex mathematics to simulate how Pluto and other celestial bodies interact gravitationally. By tweaking small variables, astronomers can see how tiny changes can drastically alter Pluto's long-term orbit. In the late 1980s, these simulations revealed something fascinating. Aspects of Pluto's orbit could be stabilized by things like an IML and scope vibration, yet it can still be erratic. Even the smallest variations in Pluto's initial position or velocity can lead to dramatic changes in its orbit over extended periods. Despite what appears to be chaos, Pluto's orbit remains relatively stable, enduring for billions of years. This shows that even though its path may seem chaotic, there is an underlying order to it, predicting events in space and time, especially those that involve chaotic orbits like Pluto's, is a formidable challenge. The unpredictable nature of these systems means that long-term predictions are fraught with uncertainties. While simulations are invaluable tools for understanding and predicting how the heavens will move bodies, they also highlight the limitations of our predictive capabilities. Any slight error in initial conditions can lead to drastically different outcomes, making precise predictions nearly impossible. The chaotic nature of Pluto's orbit serves as a reminder of the ever-changing and dynamic universe we live in, even as we make significant progress in space exploration and understanding the cosmos. Pluto's orbit reminds us of how much is yet to be determined. Understanding the gravitational interactions of giant planets on Pluto provides important perspectives on the larger dynamics of the solar system. It reveals how the positioning of each planet can have far-reaching effects, influencing the stability and trajectory of other bodies within the system. So why are astronomers expressing concerns regarding a possible collision between Pluto and Neptune now, after all these years? Neil deGrasse Tyson, a leading astrophysicist and an influential figure in popularizing the study of cosmology, offers an insightful point of view. Known for advocating the reclassification of Pluto as a dwarf planet, Tyson believes that this shift reflects our ever-growing understanding of the solar system. He does not view Pluto's reclassification as a demotion, but rather as an evolution in our knowledge of the numerous bodies orbiting our Sun. Tyson's approach to celestial mechanics is rooted in continuous learning. He sees Pluto's erratic orbit as a sign of how much more there is to discover in space. The fascination with unknowns, such as the potential for catastrophic events between Pluto and Neptune, continues to captivate scientists and the general public alike. Tyson's predictions about Pluto's future take into account its highly irregular orbit, acknowledging that anything from a close flyby to a catastrophic collision remains within the realm of possibility. Michio Kaku, another renowned physicist, joins the chorus of experts raising concerns about Pluto's long-term future. Known for his work in theoretical physics, Kaku delves into the mathematics behind the potential interactions between Pluto and Neptune. His theories suggest that while Pluto's orbit appears stable today, its future remains uncertain. He warns that, over time, even minor shifts in the forces of gravity between Pluto, Neptune, and other planets could lead to a catastrophic event. Kaku's predictions underscore the vulnerability of Pluto's orbit despite its present stability. As we continue to probe the cosmic mechanisms at play, it's essential to think about the orbit of Pluto in the future. Despite the fact that current models suggest that a collision with Neptune is highly unlikely in the near future, the unpredictable nature of celestial dynamics means that we can never fully rule out such a possibility. Gravitational interactions with other celestial bodies will continue to shape Pluto's trajectory. Even the gradual transformation of the Sun into a red giant and its eventual collapse into a white dwarf could alter the gravitational landscape of the solar system, potentially affecting Pluto's orbit. While the likelihood of Pluto colliding with Neptune anytime soon seems remote, the inherent uncertainty in predicting celestial dynamics over such vast timescales means that anything is possible. The forces at play in orbital mechanics are powerful and intricate, and even the slightest change can accumulate over billions of years, potentially leading to major shifts in the orbits of distant objects. This uncertainty in space exploration brings us back to a fundamental idea. The more we understand the universe, the more we realize how much remains unknown. The study of Pluto and other distant objects in our solar system continues to challenge our understanding of planetary orbits, gravitational interactions, and the fundamental laws governing the universe. As scientists continue to observe Pluto and Neptune, new data may either reinforce or challenge our current theories. While the idea of a disastrous collision between Pluto and Neptune might seem far-fetched, it serves as a reminder of the mystery space still holds. As our tools for space exploration advance, providing us with more accurate ways to simulate, predict, and observe these cosmic phenomena, the potential for a near miss or collision between Pluto and Neptune remains a compelling example of the complexity and unpredictability of our solar system. Whether such an event will ever take place is unknown, but it highlights the ever-changing nature of our cosmic environment. The story of Pluto's orbit invites us to think beyond what we currently know and to embrace the mystery of space. It tests our ability to look at the universe with fresh perspectives and to continue being open to the surprises that lie ahead. As scientists continue to unravel the mysteries of the cosmos, we are reminded that we have only scratched the surface of what the universe has in store. Whether Pluto and Neptune will continue to orbit safely or one day experience a cosmic collision remains an open question, one that only time and further discoveries will answer.